Hello everybody, welcome back to Online Algebra. We're going to do 10.4 today, solving radical equations, and that actually finishes us up for chapter 10. So let's jump right in. How would you solve x squared is equal to 9? And then once you think about that, think about what about square root of x is equal to 9? So how do you solve x squared is equal to 9? Well, remember, to get rid of a square, what do we have to do? We have to take the square root. So if we have x squared is equal to 9, we have to take the square root. The square root and the square cancel each other out, and we'd be left with x is equal to positive or negative 3. Now we're going to have to be careful with this today. When we're dealing with square roots, we'll only be looking at positives for the most part today. Okay, so what about the square root of x is equal to 9? Well, we said squares and square roots cancel each other out, so all we're going to do is we're going to square each of these to cancel them out. Right? This would cancel out, and we'd be left with x is equal to 81. All right, so today we're doing solving radical equations. What exactly is a radical equation? Well, once again, it has to be an equation. It needs an equal sign. And what makes it radical? Well, it's an equation, right? So we said the first part is it's an equation. So we have an equation and a radical. That talks about the square roots. So what this needs is it needs to be an equation with the variable under the square root, or the variable in the radicand. Remember when we were talking about this in chapter 9, the radicand is just another name for that square root. So here are some examples of some things that are not radical equations and some that are. So the square root of x would not be a radical equation. Why is this not a radical equation? It's not equal to anything. What would be is the square root of x is equal to 1. Okay. Another example of what would not be. X plus the square root of 9 is equal to 3. Why is this not a radical equation? Well, our variable isn't in the square root. So, not a radical equation. What would be? The square root of x plus 9 is equal to 3. Now our variable is in the square root. So we need to have that variable in the square root for this to be a radical equation. All right, how do we solve a radical equation? We have some steps. It's pretty simple, pretty similar to what we've seen before. The first step, just like we talked about very early in the year, you want to get the radical by itself. So just like when we were talking absolute values, we need to get that by itself. If we had something like the square root of x plus 7 is equal to 16, this square root acts as a jail. So we need to get everything away from that. So our first step would be to do square root, and we would move this over to the other side. Step 2, how do we get rid of the radical? Well, we're going to square both sides. So once you get it by itself, we can square this so that the square and the square root cancel. What would that leave us with? That would leave us with x is equal to 81. Step 3 is going to be solve for whatever remains. And step 4 is going to be check your answer. And now I know we always say that, but this is super important here. So make sure you underline it, star it, do whatever you need to remember that we need to be doing this every time, especially with these problems. Okay, so check your answers. Put that back in. We have the square root of 81 plus 7 is equal to 16. I don't know what that 7 is. Square root of 81 is 9, so we get 9 plus 7 is equal to 16. And this is what I was talking about. When you have a square root like this, we're going to treat it as a positive square root. So we're just looking for positive square root. All right, so simple as that. Get the radical by itself, square it, solve, and then double check your answer. Let's do some practice with this. So the first one, let's say you have the square root of x minus 5 is equal to negative 2. Step 1 is to get the radical by itself. How do we get this by itself? We add 5 to the other side. So we get square root of x is equal to 3. Step 2, square both sides. So we can get rid of this. Those two cancel. And what are we left with? We're left with x is equal to 9. Step 3, solve, but we're all good. Step 4, check your answer. Put this back in, make sure it works. So the square root of 9 minus 5 is equal to negative 2. Is this true? We get 3 minus 5 is equal to negative 2. This is correct, so this is our answer. All right, let's do one that's a little bit harder here. Let's look at the square root of 5t minus 11 is equal to the square root of t plus 5. Oh no, what do? We have square roots on both sides. We cannot get the radical by itself. Well, so all we're going to do, right, we have two square roots. What happens if we square these, right? We said a square and a square root cancel out. So squaring this means this square root will cancel out, and squaring it means this square root will cancel out. So what happens when you have a square root on both sides and you square it? You're just left with what's inside on both sides. So right, squaring means that these will both cancel out, means we can move on to step 3. Step 3 being solving. So what are we going to do? Got to get this t over to the other side. 4t minus 11 is equal to 5. Finish solving, so we get 4t is equal to 16, or t is equal to 4. But we are not done here. Why are we not done? We have to check this. So now we have to put this back into our original equation, make sure it works. So it's the square root of 5 times 4 minus, it's the square root of 5 times 4 minus 11 equal to the square root of 4 plus 5. So is the square root of 20 minus 11 equal to the square root of 9? Or is the square root of 9 equal to the square root of 9? Yes, we're all good. So now we're good. Now this is our answer. All right, let's move on. Going to keep escalating up the difficulty, keep ramping up the difficulty. Let's look at another one. Let's say we're looking at the square root of 3y plus 8 is equal to 2. Step 1, we got to get this by itself. So going to move that over to the other side. We get the square root of 3y is equal to negative 6. Going to square these to get rid of that square root. And what are we left with? We're left with 3y is equal to negative 6 times negative 6 is positive 36. Now we solve, divide by 3, we get y is equal to 12. All right, we're all done, right? No, gotta check this. So let's go ahead and check this, put it back in. We get the square root of 3 times 12 plus 8 is equal to 2, or the square root of 36 plus 8 is equal to 2. Square root of 36 becomes 6. So we get 6 plus 8 is equal to 2. Now wait just a minute. This is not correct, right? This is 14, this is 2. So what is wrong here? Well, what happened is this is actually wrong. We're getting something that we call an extraneous solution here. So this is an extraneous solution. What is an extraneous solution? It's an answer that when you sub it back in, doesn't work. And this is why it's so important to actually be checking each of these, because we could be getting answers that don't work. If the answers don't work, then we have to cross them out. They're actually not answers. They're extraneous. They're extra. How do we check these? We're going to just check these by subbing our answers in. So we have to be on the lookout when we're solving these for any solutions that look like they work, but when we put them in, they don't actually work. Those are our extraneous solutions. All right, so let's do one more to work with some extraneous solutions, and this is also going to be the hardest one we have. Let's say we have n is equal to the square root of n plus 2. Okay, step 1, get the square root by itself. We're all good. Move on to squaring. So this square and that cancel out. N squared is equal to n plus 2. Oh no, we're dealing with a quadratic now. So we're not going to be able to just solve this simply. Now we have to go back to chapter 9 in figuring out how we solve a quadratic. And how did we do that? Well, we had to get everything over to one side. We had to get one side equal to 0. So our first step is going to be get one side equal to 0. Now we have a quadratic on this side. What did we have to do to solve this? Well, remember our ACB charts? We had to factor that. That's right. Everything is coming back around. All that stuff in chapter 9 is getting applied here. So we're looking for factors of -2 that add up to -1. If we try -2 and +1, that comes out to be -1. So we're all good. Remember, we split this up, so this becomes n squared minus 2n plus 1n minus 2 is equal to 0. And then we throw everything into parentheses here and factor out what we need. So can factor n out of both of those. We're left with this. So we find out that n minus 2 times n plus 1 is equal to 0. Are we done yet? Not even close. These are a pain. So what did we have to do from here? Well, we said this means that either one of these or the other will be true. So we had to split this up and then solve from there. So we get two possible solutions here. We get n is equal to 2 and n is equal to 1. Now we're done, right? Nope. Now we have to check these. So now we're going to put both of these in to make sure that they work. We have 2 and -1. Let's check those. Let's check 2. So we get 2 is equal to the square root of 2 plus 2, or 2 is equal to the square root of 4. 2 is good to go. What about -1? Well, we get -1 is equal to the square root of -1 plus 2. And we get -1 is equal to the square root of 1. Now this might look true, but remember what we said. This is only the positive one we're looking for. So the positive square root of 1 is 1. This is saying -1 is equal to 1. And that is definitely false. So -1 does not work. These are a pain. Extraneous solutions are a pain. This is why we have to check for them to make sure that we're not lying in math here. Got to make sure we're just telling the truth. All right, that's all for this lesson, so let's get you to some practice problems. Gonna have 4 practice problems for you. The first one, you're gonna solve the square root of 3x plus 10 is equal to 16. Second one, you're gonna solve square root of s plus 10 is equal to the square root of 6 minus s. Third one, you're going to look at x is equal to the square root of 2x plus 3. And then the fourth one, I just want you telling me whether either of these two solutions are extraneous. So your equation is -z is equal to the square root of -z plus 6, and your two possible answers are z is equal to -3 and z is equal to 2. Remember what I said about how we check extraneous solutions. We have to substitute these in. So all right, go ahead and do these. Pause the video, make sure you're actually doing them, and come back to me. Pause the video. All right, welcome back. Let's get to this. First step, get the square root by itself. Second step, square. Third step, that cancels that out. Oh, and that is not 6, that is going to be 36. Third step, solve. Fourth step, double check that. So make sure that the square root of 3 times 12 plus 10 is equal to 16. Is the square root of 36 plus 10 equal to 16? Well, this is 6 plus 10, so that does equal 16. We are good to go. All right, problem 2. We can't get the square roots by themselves, meaning we're going to start by just squaring both sides. It's going to cancel these out, and we get s plus 10 is equal to 6 minus s. Now we're going to solve. We got to get all the s's to one side and get everything else to the other side. Finish solving, we get s is equal to -2. Make sure you check these as well. So put this in. Let's do a check in a different color. Get the square root of -2 plus 10 is equal to the square root of 6 minus -2. Okay, -2 plus 10, that's going to be 8, and 6 minus -2 is the same thing as 6 plus 2. So it's equal to the square root of 8. That one is good to go. Problem 3. We have the square root by itself, meaning we are going to square both sides. We get x squared is equal to 2x plus 3. Right, these cancel out. Now we have to get everything to one side, so this becomes x squared minus 2x minus 3 is equal to 0. When we make our ACB chart, we're looking for factors of -3 that add up to -2. It's going to be -3 and +1. So this becomes x minus 3 times x plus 1 is equal to 0. Split this up, so it becomes x minus 3 is equal to 0, or x plus 1 is equal to 0. And we get that our answers are going to be 3 and -1. Remember, we are not done, even though this problem is extra long. Now we have to check these. So now we have to see whether 3 squared is equal to the square root of 2 times 3 plus 3. So is 9 equal to the square root of 6 plus 3? Did I do that right? I did. So is 9 equal to the square root of 9? That is not true. So that is not a correct answer. Right, what about the other one? Is -1 squared equal to the square root of 2 times -1 plus 3? -1 times -1 is +1. Is that equal to the square root of -2 plus 3? Or is 1 equal to the square root of 1? That is true, so that is our remaining answer. All right, in problem 4, this was a little bit of a curveball, but all we have to do is sub these in to make sure that they work. So we're going to use -3. We're going to see, is -3 equal to the square root of -3 plus 6? Or is negative times negative positive, square root of +3 plus 6? Is 3 equal to the square root of 9? It is, so this one is all good. What about 2? Well, is -2 equal to the square root of -2 plus 6? Or is -2 equal to the square root of 4? Remember, this is positive, so this is -2 is equal to 2. That is a no-go. So this is incorrect. This one is extraneous. All right, that's all we have. Go ahead and get going on the homework. And then once you're finished with that, we have some review of the entire chapter.